Okay. Good morning to one and all. So, in the previous practical, we have discussed regarding one experiment. That is one of the practical. Is that the speed control, and also we have discussed one of the practical in the last practical is that to determine the efficiency of DC shunt motor, to determine the efficiency of the DC shunt motor by performing Swinburne test. Okay, so this practical we have seen in the previous lecture. No, हे practical आपण बघितले ना पाठीमागच्या लेक्चर मध्ये.
Yes, sir.
Okay, now see, today we will discuss about the next one practical. Is that to determine the efficiency of DC series motor by performing load test. Okay, so to determine the efficiency of DC series motor by performing load test. See, similar to that is title of today's experiment is that determination of efficiency of DC series motor by conducting load test. Aim of this experiment is that to obtain the performance characteristics of DC series motor by using a load test. Okay, sorry for interruption. Due to network issue, we have lost the connection. Okay, see, the title of experiment is that to determine the efficiency of DC series motor by conducting a load test. So aim of this experiment is that to obtain the performance characteristics. That means by conducting test, we want to determine the characteristics like speed versus armature current characteristics or efficiency versus output power characteristics. So this graph we want to draw after performing the test. See, aim to obtain the performance characteristics of DC series motor by using a direct load or by conducting a direct test. Okay, so apparatus required for conducting this test is nothing but we require one of the ammeter, and the range of that ammeter is nothing but it is 0 to 20 ampere or it may be 0 to 10 ampere. It is according to rating of the machine. So it is required one quantity. To measure the supply voltage, we required one of the voltmeter having a range 0 to 300 volt. And to measure the speed of DC series motor, we require one of the tachometer. So we have taken here one tachometer and some of the connecting wires are required. Okay, so these are the apparatus required to conduct a test. Okay, see, while performing any test or while conducting a test on DC series motor, what is the precaution? We have already discussed in the theory. What should be the precaution it is to be taken while conducting any test on DC series motor? काय precaution घेतली जाते? Yes, give me reply immediately. What is the precaution in case of DC series motor? While running a DC series motor or while starting a DC series motor, what precaution should be taken? Because we have already discussed regarding characteristics of DC series motor, in that torque versus armature current characteristics, speed versus armature current characteristics, and speed torque characteristics we have already derived in the theory. Also, I have given a proof for that also. What is the precaution?
No load run karane.
Okay, so that means DC series motor, it is never be started on without load. somewhat load it can be putted on DC series motor. What is the reason behind it? Why it cannot be running on no load condition?
They will run dangerously.
At no load condition, that means at a minimum value of current, the speed of the DC series motor it can be obtained dangerously high, so that DC series motor it never be started on without load. Okay, so somewhat load, that means near about 25% load it can be putted on DC series motor, and on that load we are starting a DC series. So this precaution all of you keep in mind, that is the motor should be started and stopped with 25% of rated load. Near about 25% load it can be required, because of this motor it is having a high starting torque. At a minimum value of current or at a no load condition, the speed of DC series motor it can be obtained very high or huge speed. Due to that the machine brushes or it may be commutator segment it can be somewhat damaged. Okay, so somewhat load it can be putted on the DC series motor. So similarly we have understood the application regarding that. Application पण आपण बघितले होते. So generally DC series motor it can be used where somewhat load it should be present on the motor. Okay, मोटरवरती काहीतरी लोड प्रेझेंट आहे, त्या कंडिशन मध्ये आपण काय करू शकतो, मशीन यूज करू शकतो. सो जनरली ऑल्सो आय हॅव टेल दॅट the DC series motor it never be started on belt connected load, or it may be it is never be used where the belt connected load is there. In case of gear or it may be chain connected load is there, we are using a DC series motor. Second one is that the brake drum should be cooled with the water when it is under load condition. Okay, due to high speed or the high starting torque of the motor, due to that high speed, if we are directly applying mechanical load by using a belt and pulley arrangement, so due to that belt arrangement there is a friction, or high speed there is a more friction it will be occur. So that due to that more friction there is a maximum heat dissipation is there, right? No, maximum friction असल्यामुळे त्याच्यामध्ये heat dissipation जे असेल ते maximum असेल. So due to maximum heat dissipation, we required a brake drum cooling arrangement, or it may be it should be cooled by using a water. Water चा use करून आपण काय करू शकतो, cool करू शकतो. Okay, so this is first one precaution should be taken. Now see the schematic diagram or connection diagram while performing or conducting a test. See the positive supply of the power supply, that is positive and negative supply. Positive it can be connected to one terminal of the ammeter. Next terminal of the ammeter it can be connected to L terminal of the 2-point starter. Okay, here in case of DC series motor, the field winding it is connected in series with that of armature winding, so there is a no separate field terminal. Okay, so starter it is used like a 2-point starter it is used, that is line terminal and armature terminal, only two terminal or the 2-point it is required. So we are using a 2-point starter. Here आपण 2-point starter काय करतोय, use करतोय. Okay, now armature terminal of the 2-point starter it can be connected to one terminal of the winding, field winding. Next terminal of the field winding it is connected to A1 terminal of the armature. Next terminal of the armature, that is A2, it is connected to negative terminal of the supply च्या negative terminal. To measure the supply voltage we required one of the voltmeter, so it is connected in parallel with that of supply terminal. Positive आणि negative च्या across मध्ये आपण काय केले, एक voltmeter connect केले. And here the mechanical loading arrangement is done. So we are applying the mechanical load, it is in kg मध्ये आपण mechanical load apply करणार. So this load, that is mechanical load, it can be applied by varying this wheel, or this is one pony brake arrangement, and this reading shown be reading it can be shown here, S1 and S2, that is spring balance reading it can be shown here. So S1 and S2 it will show the spring balance reading, or how much force it can be applied to that of pulley. Okay, So we have already conducted one load test of DC shunt motor. So similar to that, we are gradually applying load to the top DC series motor by rotating the pulley, and we are calculating the torque. After calculation of the torque, formula for torque is nothing but T is equals to S1 minus S2, that is spring balance, difference between spring balance, into radius of the drum, and we want to convert it into Newton, so we are using 9.81, multiplication of 9.81. Okay, see, this S1 minus S2, we are taking a spring balance, S1 minus S2 into drum radius R into 9.81. Once torque it can be calculated, then we are able to calculate the power output, that is mechanical power output. What is the formula for calculating power output? P out. काय formula आहे? P out चा formula काय आहे? Power output. पॉवर आउटचा फॉर्म्युला काय?
VL into IL.
पॉवर आउटपुट म्हणतोय मी, मेकॅनिकल पी आउटचा फॉर्म्युला. आपण एफिशियन्सी कॅल्क्युलेट केली डीसी शंट मोटरची, टॉर्क वरून काय फॉर्म्युला? VL into IL is nothing but electrical input power. V आहे आपल्याकडे, करंट आहे, so that VL into IL is nothing but input power. What is the formula for P out? टॉर्क इक्वेशन डिराइव करताना आपण बघितला होता फॉर्म्युला.
Input into total power, total loss.
I am having the value of torque. टॉर्क ची व्हॅल्यू माझ्याकडे आहे, टॉर्क वरून मला आउटपुट पॉवर कॅल्क्युलेट करायचे. देन सांगा. You people don't know formula. P out is equals to 2 pi NT divided by 60. So power output, it is nothing but 2 pi NT divided by 60. I am having the value of torque. I am having the value of speed, that is N, and 2 pi it is constant, 60 it is also constant. So power output, it is equals to 2 pi NT divided by 60. Once power output it can be calculated, and the input power it can be calculated by using the supply voltage V and the armature current A, supply voltage V, and this line current, or it may be armature current A, which is read by ammeter. We are able to calculate the power input. Okay, and once P out and P in it can be calculated, we are able to calculate the efficiency. त्याच्यावरून आपण efficiency काय करू शकतो? Calculate करू शकतो. See, the procedure for that, the connection are given as per the circuit diagram. Observing the precaution, and then a DPST switch it can be closed. So first of all, consider the precaution, that is load should be put on the motor near about 25% load, or it may be drum, it is nothing but water cooled drum is there. So if we observe this precaution, then close that DPST switch, double pole single through switch. The motor is started with the help of 2-point starter. So we have discussed regarding starter. Gradually we are varying the we are moving the arm of the 2-point starter and we are gradually cutouting the armature resistance. So if the armature resistance is gradually cut out, then the armature current, it will be gradually increases, and at the on position, the total resistance, it should be cut outed from the series of armature, and the armature, it will be carry a rated current or it may be full load current. See, load on the motor is varied with the help of pony brake arrangement. That means by using a wheel and pony brake arrangement, we are varying a load, or we are putting the load, and we are note downing or reading can be taken by spring balance, ammeter reading, voltmeter, and the speed readings are noted down for various line currents as the load is applied, and the care must be taken to avoid the speed reaching dangerously high. ही केअर घेतली पाहिजे. That means we want to care about the speed of DC series motor should not be goes to dangerously high value while we are reducing the load. While we are reducing the load, the speed should not be goes dangerously high value. Okay, so these are the and then at the minimum safe load, or it may be near about 25% load, we are opening the DPST switch. That means we are stopping the motor. Okay, so disconnect the connected apparatus, or which apparatus can be connected. We are disconnecting this apparatus, and we are concluding our test. Okay, now see observation table. All of you take screenshot for that. Which reading we want to take? We want to take the supply voltage reading VL, then line current, that is IL, then we want to measure the speed. So see, we want to see the S1 and S2, that is spring balances S1 and S2. We want to take difference between this S1 and S2. After that, we want to calculate the value of torque. So torque, formula for torque is nothing but torque S1 minus S2, that is spring balance, difference between spring balance, into a drum radius R into 9.81. So it will be obtained in Newton. Okay, that is Newton meter. Now output power, it can be calculated by using a formula, that is P out is equals to 2 pi NT divided by 60, where N is nothing but speed, T is nothing but torque, whichever calculated, and 2 pi and 60 are constant. We are using this formula and calculating output power. Okay, then input power is nothing but supply voltage V and line current I. Multiplication of this is nothing but input power. Once power input and output power you people know, then we are able to calculate the efficiency according to formula output power divided by input power into 100. So we will get the efficiency, it is in the percentage. Okay, so all of you take screenshot for observation table. Now sample calculation is given. Circumference of the brake drum, it is in the centimeter, or it may be it is in the meter. So we want to calculate it into meter. Centimeter मध्ये आपण measure करणार, calculation meter मध्ये करणार. Then we want to calculate the torque S1 minus S2 into drum radius R into 9.81. It is comes into Newton meter. We are calculating input power, that is Pi is equals to supply voltage V into line current I, Pi. Output power, it is equals to 2 pi NT divided by 60. N is nothing but speed, T is nothing but torque, 60 and 2 pi are constant. So we will get the output power. And after that, output power efficiency, that is we are calculating efficiency at each and every reading. So efficiency, it is equals to output power divided by input power into 100. So we will get the efficiency. Okay, now after that we want to determine this graph, or we want to plot the graph according to reading. So we want to plot a first graph, that is speed versus output power. Speed चा आणि output power चा graph आपल्याला calculate करायचे. Then second one graph is nothing but torque versus output power, that is torque versus output power, and we want to plot third one graph, that is efficiency versus output power. Okay, baga, torque versus output power, it shows as the linear proportion. That means as the output or as the torque increases, the output power of the DC series motor, it will be increases. Baga, किंवा if output power increases, that means the torque of the machine it will be increases. It shows that the linear relationship and the curve it will be starting from origin or it may be zero position. See, this line shows that the torque versus output power characteristics. After that, after that, we want to calculate the efficiency versus output power characteristics. So see, efficiency versus output power. If output power it will be increasing, then efficiency is also increasing at a somewhat minimum output power. There is a efficiency it will be present, some efficiency. After that it will be start increasing with increase in the output. And we see the speed versus output power. As the output power it will be increases, the speed of DC series motor it will be decreases. Speed काय होते decrease होते. So these characteristics you people want to determine or it may be. Okay, see, and lastly we will write the result. The load test on the given DC series motor was conducted and its performance characteristics were drawn. So we want to write this result, that is the load test on the DC series motor it can be conducted and its performance characteristics were drawn. त्याची performance characteristics काय केले drawn केले. Okay, so all of you understood this theory.
Yes, sir.
Okay, now we will do the performance of the DC series motor by conducting this test. I will stop sharing. Hello. Hello. Screen is visible.
Yes, sir.
Okay. See. Okay. So this is series motor panel. We want to do the connection. So I think all of you understood the connection. First of all, we want to connect one of the ammeter, that is here it is positive and negative supply. See, here it is positive and negative supply. Here the positive and negative supply. We want to connect this positive supply to the 2-point starter. Here this one is the 2-point starter of DC series motor. DC series motor is 2-point starter having a 2 terminal, that is line terminal and armature terminal, L terminal and A terminal. See, we want to connect one ammeter in series with line to that is positive terminal to the line. See, we are connecting one positive terminal to that of one of the ammeter. Here is ammeter. Okay. Now, next terminal of the ammeter, where it can be connected. Ammeterचं नेक्स्ट टर्मिनल कुठं कनेक्ट करायचं आहे? Here we want to connect the next terminal of the ammeter. See, okay. इको होते का? Hello, audible no? Am I?
Yes, sir.
Yes, sir.
Positive terminal of the supply, it can be connected to the one terminal of the ammeter. Now next terminal of the ammeter, it can be connected to line terminal of the 2-point starter. 2-point starter चा line terminal ला connect करायचं. Okay. So here this one is the next terminal of the ammeter. It can be connected to the one line terminal of the 2-point starter. Here it is line terminal of the 2-point starter. Okay. Now next armature terminal of the 2-point starter. कुठं कनेक्ट केलेलं आहे armature terminal? A terminal, that is A terminal of the 2-point starter. It can be connected to the one field terminal. Field से F1 terminal ला connect करो और we can represent at Z. Into a y ने represent करके करा करेंगे. Okay. Now next terminal, that is next terminal of the field winding, it can be connected to one terminal of the armature. See here it is next terminal of the field winding. It can be connected to the one terminal of the armature. Armature से एका terminal ला connect. Next terminal of the armature, जे काय armature चं next terminal आहे. So see, we want to connect this next terminal of the armature to the negative. Right now, बरोबर ना? So
Yes, sir.
I am connecting it to negative. Now to measure the supply voltage, for measurement of supply voltage, we want to connect one of the voltmeter. एक voltmeter आपल्याला connect करावं लागेल. So this voltmeter, it can be connected across positive and negative supply. Positive and negative supply चे across मध्ये connect करो. So first terminal I have connected here positive. Second terminal I have connected to negative. Okay. And here we require one of the voltage. एक voltage DC having a range 300 volt. I have connected it positive and here it is negative. See connection बघा. Positive terminal of the supply, it can be connected to one terminal of the emitter. Next terminal of the emitter, it can be connected to N terminal of the 2-point starter. A terminal of the 2-point starter, it is connected to one F1 terminal of the field winding, or we can represent Z1, Z2, or we can represent Z double Z. Right now, or we can represent S double S. Represent करू शकतो. Next one, next terminal of the field winding, it can be connected to the one of the armature terminal. Armature terminal ला काय केलं? Connected. And then armature next terminal, it can be connected to negative. And for measurement of supply voltage, we require one of the voltmeter in across the positive and negative. So we have connected to voltmeter. Now we want to take the reading of voltmeter. We want to take the reading of ammeter, that is line current, supply voltage, or it may be applied voltage. Then we want to apply load to the machine. Machine का अपन load apply करता है. So this load it can be applied, and we want to take the spring balance S1 and S2. Somewhat load should be present while starting a DC series. So I have kept some of the load on the board. We want to measure the radius of this drum. Turns the radius to measure connection, and we are able to calculate the torque. Once torque it can be calculated. After that, we are calculating the power output, that is P out. And when the power output it can be calculated and power input it can be calculated, we are able to calculate the efficiency of DC series motor. Okay, DC series motor efficiency. See, the precaution should be taken. Somewhat load should be present on the top machine. Present by. So see, near about 25% load should be present on the machine. Okay, बघा मी काहीतरी load apply केली आहे. So हा drum जो आहे, somewhat load it can be applied to the top machine. That is, some load should be present before starting of DC series. Okay, so this is the simple connection. I think all of you understood the connection. याच्यामध्ये मला काही doubt आहे का? Connection लक्षात आलं का?
Yes.
Okay. Now we will start the DC series motor. First of all, I will start the DC supply. Okay. See, I have switched on the MCB or switch. What is the reading of voltmeter? Voltmeter shows some of the reading. What is the value of voltage applied? Voltage ची value किती आहे? What is the value of voltage? आवाज येतोय का माझा?
Yes, sir.
What is the value of voltage? I will showing you. Just tell me only of voltage. किती आहे value? It will show some of the value. It is near about 92, right? No. So if I have connected, it is to 300. So double of that. That means 92 into 92. Oh, sorry, 92 into 2. किती 184, no?
Yes, sir.
Okay. Now, by varying this arm of 2-point starter, I am starting the DC series motor. Okay. By slowly or gradually cut outing the resistor, I am starting the DC series motor. Okay, see, the DC series motor is started. Well, we will check the speed of DC series motor. Check the speed of DC series motor. Somewhat low is present on machine. DC machine वरती DC machine वरती काहीतरी load present आहे and somewhat load should be present and DC series motor running on somewhat speed. So all of you take the reading of speed 1835. 835. Now see at the time of this value of current, with the value of current. किती current ची value?
3.2.
किती value आहे? Hmm. What is the problem? It can be happen. Why the handle it can be not stay at all position? What is the problem? काय प्रॉब्लेम होतो सांगा. Okay. Due to insufficient flux produced at the hold on coil, the electromagnetic force produced by hold on coil it is not sufficient, so that's handle it will be not hold by this starter. Okay, so we are just doing that. Okay, see at that situation, see the value of current. Current value बघा. Here it is 3. In between 3 there are here it is 3.5. In between that means 3.25. 3.25 value of the current. Voltage we have already seen. Value of voltage is nothing but 94 into 2, so it is nothing but 188. Now we will check the speed. Speed of the DC series motor, it is nothing but 1818. Speed of DC series motor, it is nothing but 1818. Now we will increase the load on the DC series motor. Load can increase the value of value. S1 is equals to 5, S2 is equals to 1. S2 is equals to 5, S3 is equals to 1. 1880. Now, I am just supplying load. Again, I will increase the load. See, load on the DC series motor is near about 6 kg. S1 is equals to 6 kg.
सर वॉइस स्लो येते जरा.
S1 is equals to 6. S2 is equals to 1.5. S1 is equals to 6 and S2 it is equals to 1.5. Now we will check the speed. See the speed 1706. 1706. At that time, see the value of current. Value of current. The current value it is increases, so it is near about
3.75. Okay, 3.75. Voltage remains same. 94 into 2, it is nothing but 188. Again, we will increase the load. See, the load on the DC series motor we have increased. So this load, it is near about S1 is equals to 7 kg, S2 it is equals to 2 kg. S1 it is equals to 7, S2 it is equals to 2. Now we will check the speed. 1575. 1575. Now check the value of current. Value of current, it is nothing but 4.5. Near about 4.5. Voltage remains same. Okay. So we will take only 3 readings because DC series motor it is having a maximum speed. So we cannot run this motor for a long time. Okay. We will stop. Now I am reducing the load.
Hello. Understood? No? We have taken only 3 reading because DC series motor it cannot be run for long time when the mechanical loading like a pony brake arrangement or the via belt load is there. Because of due to high friction there is a maximum friction, the maximum heat dissipation is there. त्याच्यामध्ये maximum heat dissipation असेल. Due to that maximum heat dissipation, somewhat belt it may be damaged, or it may be somewhat the belt it may be damaged, or it may be due to that friction and heat the belt of the machine it will be damaged. So that we have taken only 3 reading. Okay, all of you understood? लक्षात आलं का तुमच्या? Only 3 reading we have taken. From that 3 reading, can anyone tell me any conclusion? What happened regarding current? Current काय होत होता?
increase होतं.
Okay, current it will be start increasing. That means when load increases, the current of the machine it will be start increasing. Again, what about torque? We want to calculate the torque. If load increases, obviously torque it can be increases because S1 minus S2. We want to take difference. And the speed. What about speed? Speed मध्ये काय change होत होता?
decrease.
Speed decreasing. Okay. आउटपुट पॉवर इन्क्रीज होत असेल त्यावेळेस स्पीड काय होतं? डिक्रीज होते. किंवा आपण लोड इन्क्रीज केला की आउटपुट पॉवर इन्क्रीज होईल. So the speed of the DC series motor it will be decreases. And all of you calculate the efficiency. Then tell me how the efficiency graph it will becomes. Speed is also decreasing. Initially we got the speed 1800 and 18 or 35. 18 no? किती घेतले रीडिंग पहिलं? First one reading
1818.
18. Okay. Then we got the speed 1705 something. After that we got a speed of 1575. Okay, so that means speed it is decreasing, current increasing, voltage, that is supply voltage, remains constant. All of you do calculation and calculate the efficiency of the DC series motor. Okay, DC series motor ची efficiency काय करायची, calculate करायची. Now I will tell the radius of the drum ची radius. Just 1 minute. Drum ची radius. Okay, after that I will tell the radius of the drum in the lecture slot, because I am not having the scale right now to measure the radius. I will measure and I will tell in the at the time of lecture. Okay, so hence we will conclude this today's practical and we will stop here. Thank you. कोणाला काही डाऊट आहे का याच्यामध्ये? Is there any doubt? Hello, give me reply.
No, sir.
No, sir.
Okay, we will conclude and we will stop here. Thank you.